Problem number 2. The bus comes to a stop near your house every day at a random time between 7:15 and 7:20 a.m. You arrive at the bus stop at a random time between 7:10 and 7:15 a.m. every day and wait until the bus comes. What is the probability that you will wait less than 4 minutes? All right, well, let's think about this. So you're arriving definitely before the bus gets there, or exactly at the same time. If you get there at 7:15 and the bus comes at 7:15. Okay, so if you come at 7:10, you know you'll wait at least 5 minutes, but it could be as much as 10 minutes, right? And if you come at 7:15, it's either somewhere between 0 and 5. So let's see if we can somehow graphically represent the time you have to wait for the bus, okay? Depending on what time you get there and what time the bus gets there, all right? And so in order to do that, I'm going to, I'm going to draw a graph here. And I'm going to plot, I'm going to make it like an XY axis. And so I'm going to plot the time that you get to the bus stop. So let's say this is 7:10, okay? And let's say 11, 12, 13, 14, 15. Let's say this is 7:15. Okay, so you arrive, at the bus at the bus stop between 7:10 and 7:15. Okay, so let's say that this is this axis here, this y-axis. So this is your arrival on this axis, and this is the bus's arrival on the other axis. Okay, and the bus gets there somewhere between 7:15 and 7:20. So 16, 17, 18, 19, 20. No, 2, 3, yeah, right here. 7:20. I think I got that. All right, and so, let me draw some dotted lines here to represent the region that we're talking about in this graph. Okay, so the bus arrives somewhere between 7:15 and 7:20, and you arrive somewhere in here. Okay. So, so we know, for example, that if you arrive at 7:15 and bus arrives at 7:15, you're not going to have to wait any time at all, right? You'll just walk right on the bus. If you arrive at 7:10, you'll wait 5 minutes. If you arrive at 7:11, then you would wait 4 minutes. And the thing that we're looking for is the probability that you will wait 4 minutes or less. So let's look at the arrival times, your arrival times, where you would, and the bus arrival times, where you would wait exactly 4 minutes, okay? Because that'll divide this region into, your wait time is less than 4 minutes, or your wait time is greater than 4 minutes, okay? So I know that this is one of the points on the boundary, all right? So the boundary between those two regions, where you wait less than 4 minutes and greater than 4 minutes, will be when you wait exactly 4 minutes. Okay, so let's see if we can find that boundary where you wait exactly 4 minutes. So one scenario is that you come at 7:11 and the bus comes at 7:15. Okay, another one would be, if you come at 7:12 and the bus comes exactly at 7:16. Okay, and if you come at 7:13 and the bus comes at 7:17, or if you get there at 7:14 and the bus comes 4 minutes later at 7:18, okay, or if you get there at 7:15 and it comes at 7:19, this line here would represent the scenario where you wait exactly 4 minutes, okay? And so let me kind of label that. So you wait exactly 4 minutes, okay? That's this diagonal line here, okay? So the region, this square region here represents all the possible times that you might wait. And and this line here is just when you wait exactly 4 minutes. So if we look at points below this diagonal line, you can obviously, that if you arrive at 7:15 and the bus arrives at 7:15, obviously that's going to be, 0. You wait 0 time. So this region down here is actually the times, or the scenarios where you wait less than 4 minutes. So you wait less than, less than 4 minutes. Okay? And this region up here, like for example, if you come at 7:10 and the bus comes at 7:20, then you've waited 10 minutes for the bus. Or if you come at, say, 7:11 and the bus comes at 7:18, then you waited 7 minutes. So this region up here, maybe I can just I'm gonna shade it with dots. This region up here is all the times that you wait more than 4 minutes, right? More than 4 minutes. Okay? So, out of all the possible times that you could wait, which is an infinite number of times, because the arrival time, for your arrival and the bus's arrival is continuous. You can arrive not just on the minute, but you can arrive at 7, 10, and 32 seconds, or 7, 18, and 15 seconds, or something like that. So there's a continuous, there's an infinite number of points in both of these regions. So you can't, it's not quite, it's not a counting problem over a counting problem like a normal, like a typical probability problem is. You can count the number of ways the desired outcomes and divide it by the number of total outcomes. But in this case, our total outcomes is this square region, but we can calculate the area of this region, right? Because we have the distance here is 5 minutes. Whoops, 5 minutes, right? From 7:20 to 7:15 to 7:20, and the distance here is also 5 minutes, right? So 5 minutes. So our probability will be this 25 minutes, minutes squared of possible times, and the region that we're interested in is this, okay, which is, it's just a triangle. So it's 1/2 base times the height, so that's 1/2. Our base could be 4 minutes, right? And our height here is also 4 minutes. So we're looking at 8 minutes, or 8 minutes squared. Alright, so we're looking at 8 minutes squared over 25 minutes squared to get the probability. Okay? Does that make sense? So the area of the region we're interested in, we're interested in the times that you wait less than 4 minutes. So the area of that is 8. The area of the whole thing is 25. So the probability will be 8 out of 25. And I don't think this is 5 times 5, and this is 2 cubed. We can't reduce it anymore. We could write that as, 25. If I take that times 4, that's 100. If I take this times 4, it's 32. So we could represent it as 32 out of 100, or 32%. way to represent. So it's either 32% of the time you're going to wait less than 4 minutes, or you could write it as 8/25ths of the time. So 32% kind of is a little easier to understand answer. If someone were to actually ask you this question, it would probably make more sense to most people to express it in terms of a percentage. So 32% of the time, you'll wait less than 4 minutes if you arrive between 7:10 and 7:15 a.m. for the bus.